Hello everyone. I hope everyone's doing great. So today's topic of discussion is data sufficiency, and in today's video we'll be looking at another set of 5 questions from the topic inequalities. Alright, so we are already done with 2 videos on inequalities. So if you're watching this data sufficiency inequality part 3, and if you haven't had a chance to go through the first 2 videos, so I would recommend you to please watch the first 2 videos also once you're done with this third video. Right, and if you're like completely new to this topic and we're not aware of the basics of inequalities, then I would actually suggest you to go to Binge's Education YouTube channel and go to the playlist section and look for the inequalities playlist, okay, and understand like how inequalities work, what are the basic concepts and all those things. All right, so in this video we have again 5 questions, and we're gonna look at them one by one. And what we will be doing is that I'm going to show you a question on screen. You're going to pause the video, you're going to try that question for by yourself first, so that like you understand how you are supposed to solve a question, and then we can probably move on further. All right, okay, then it's time for us to move on to the first question. So pause the video and try this question, please. All right, let's see how we can solve this one. So it said that r plus s is greater than 2t. R plus s is greater than 2t is r greater than t. Okay, so r plus s is greater than 2t. Let me rewrite this as r plus s is greater than t plus t. Okay, this is the fact of the question. It's like something known to us, and we need to find out if r is greater than t or no. This is what we need to find out. Okay. Now, statement number one says that t is greater than s. Now, given the fact that r plus s is greater than t plus t, r plus s is greater than t plus t, and this number here, this value here, t, is greater than this s. If this t is greater than s, can I say one thing for sure, that r has to be bigger than this t? R has to be bigger than this t. For example, let's say s is some number 8 and t is some number 9, because t is greater than s. So r plus 8 is greater than 9 plus t, or effectively it will be like 9 plus 9 only. Now what will happen is I can rewrite this as r is equal to 1 plus t. Or in other words, you could have also solved this question as the in a way that if r plus s is greater than t plus t, so r will be greater than t minus s plus t. Now what is t minus s? Now since t is greater than s, then this number has to be a positive number. So r is greater than t plus a positive number. Now you're adding a positive number in t so as to get r, or so as to get close to r. Basically you're adding something to t in order to achieve the value r, or in order to attain the value r. So I can simply say that r has to be greater than t. Whichever way you want to do it, it's completely. So yes, from the first statement, I'm able to conclude that the value of r is greater than t. Basically, I'm able to conclude a definite relationship between r and t. The point is not about an affirmative answer, right? This is something that we have already spoken of in the previous videos also. We're not looking for an affirmative answer, we're looking for a conclusive answer. So if we write D, A, B, C, E, now since A is able to give me the answer, which means B goes out, C goes out, and E goes out. If second statement is also give us a conclusive answer, then we'll go with D. If second statement alone is insufficient to give us the answer, then we'll simply go with option A. Okay, now let's move on to question number. Okay, now let's move on to the second statement, and that says that R is greater than S. and I already have r plus s greater than 2t. Add the two inequalities. So you will have 2r plus s is greater than s plus 2t. I can subtract s on both the sides. So I will get 2r is greater than 2t, which means r is greater than t. Now, why in the second case I thought of like adding the two inequalities? Because I could realize that I'm gonna have s on either sides of inequalities, and I can simply like remove s, which will actually bring me a relationship between r and t directly. Okay, so from the second statement alone also I'm able to figure out the relationship, a conclusive relationship between r and t. Hence my answer simply becomes option number D. Hence my answer simply becomes option number D. All right, then let's move on to the next question. That's question number 2. So pause the video and try this question, please. Give this one a try. Okay, let's see how we can solve this one. So I think this 2 should not be there. This is one error, but I hope everyone understands that. So first of all, let me solve this polynomial part. So we have 8xy cube plus 8x cube y. This is 2x square y square divided by 2 to the power minus 3. This is 8xy cube plus 8x cube y. Now this 2 to the power minus 3 is basically like 1 over 8. So this is going to go on the top because this will become basically 1 over 8. So this 8 is going to go to the top. This will become like 16x square y square. Now bringing everything on the one side, 8xy cube plus 8x cube y minus 16x square y square is 0. Now what we can take common is we can take 8xy common from each one of them, and we're gonna have like x square plus y square minus 2xy within bracket. So this is like 8xy, and within bracket we will have x minus y square, and that is equal to 0. So this is gonna give us like a lot of conclusions. So one is x into y is equal to 0. So in that case you can either have x is equal to 0 or y is equal to 0 or both of them equal to 0. Or we can have x minus y equal to 0, which basically tells us x is equal to y. Or the third conclusion that we can have is x into y is equal to 0 and x is equal to y. And in this case, the only possibility is x is equal to y, which is equal to 0. So these are basically the three conclusions that we have. Okay, so we have basically like simplified this polynomial and we did whatever we could, and we have drawn up our conclusions also regarding what all possibilities can we have. Okay. Okay, so the first statement is y is greater than x. Now if y is greater than x, so third possibility rules out because they have to be equal. The second possibility also rules out. Xy equal to 0 also rules out. If y is greater than x, these two are the possibilities. That is, you can have y 0, in that case x will become negative, or you can have x 0 and in that case y will become negative. Sorry, my bad, y will become positive because y is greater than x. But now in either of the two cases, since the question is about what is x into y, in either of the two cases, x into y is equal to 0. In either of the two cases, x into y is equal to 0. Do we have a conclusive answer from statement 1? Yes, we do have a conclusive answer from statement 1. Second statement says x is less than 0. That is x is negative. So if x is negative, let me do this with another color so that we are able to differentiate. So let me use blue. So second statement says that x is less than 0, that is x is negative. So this third possibility rules out. This is a possibility because this can be done. X y is equal to 0 is ruled out. X equal to 0 is also ruled out, but you can have y is equal to 0. This is possible because even if y is equal to 0, x can still be negative and still x into y will be 0. So if x is negative, one case is when x is negative, one case is when y is 0 and overall xy is 0. Another case is when x is less than 0, then y will also be less than 0 because x is equal to y. In that case, xy is positive. So do we have a conclusive answer from the second statement alone? No, we don't have a conclusive answer from the second statement alone. Hence, if we go for D, A, B, C, E, our answer is option number E. Because statement A alone is sufficient to give us the value of x into y. And that's it for this question. All right, I hope all of you have understood this question. So let's move on now. Let's move on to question number 3. Pause the video and try this question, please. Do take your time while solving these questions. These questions are actually interesting and you have like a lot of learning going through these questions. Pause the video and try this question, please. Okay, let's see what we can do with this one. So it says that P less than Q, P is less than R. So P is less than both P, Q and R. And it says that P into Q into R is P into Q into R is less than P. Okay. So is P into Q into R less than P? This is the question. This is the question. Okay. First statement says that PQ is less than 0. Now, if PQ is less than 0, product of two things is less than 0, then we can have two possibilities. P greater than 0, Q less than 0. Another possibility is P less than 0, Q greater than 0. Now, there are two facts which are given to us. One is P is less than Q, another is P less than R. I think in this one we only require P less than Q. Now if P is less than Q, if P is less than Q, can we say that we can simply eliminate this possibility? Because if P is less than Q, it's not possible for P to be positive and Q to be negative, right? It's not possible. So if P is less than Q, then P will be negative and Q will be positive. This is the only applicable case that we have. So from condition when we have P is negative and Q is positive. Okay. Now, if we use this in this given question that we have, so we have a negative number multiplied by a positive number multiplied by R is less than by a negative number. Now, even if I divide both sides by a negative number, I know that my sign of inequality will change for sure. So positive number multiplied by R is greater than 1. Now, this is the question. A positive number multiplied by R, is that number greater than 1? A positive number when multiplied by R, is that number greater than 1? Do we know the value of R? No, we don't know that. If R is positive, then also we do not know whether positive into R will be greater than 1 because it may happen that both of them are like 0.5 and 0.75. Okay, so apart from the fact that we do not know R, we actually do not know what's the value of Q also. This is another important thing which we need to understand. It's not only about R, it's also about the value of Q. Simply saying that product of two positive number will be greater than 1 will be incorrect, because it may happen one number is 1, another number is 0.25. Okay. All right. So do we have a conclusive answer? No, we don't have a conclusive answer. So what we will do is D, A, B, C, E. A goes out, D goes out. Okay. Statement number 2. PR is less than 0. So you will have P greater than 0, R less than 0. You will have P less than 0, R greater than 0. Now again, let's go back to the fact given to us. Fact is P is less than R. So if P is less than R, then we can't have P greater than 0 and R less than 0. This is not possible. This is the only possible condition. That is P is less than 0 and R is greater than 0. P is negative and R is positive. Okay, now let's use this. If we use this, so we're gonna again have negative multiplied by Q multiplied by positive less than or negative. Again, we will land up in the same place where we were in the previous statement. You're gonna have Q multiplied by a positive number greater than 1. Is that so? We don't know that. Again, the problem is neither we know the value of R, neither we know the value of Q. So we can't say anything for sure. Okay. Which means B also goes out. So the point is we need to combine both of them. So for combining both of them, what we have is we have P as negative, we have Q as positive, and we have R as positive. So negative number multiplied by positive number multiplied by positive number is less than a negative number. Divide both sides by negative. Positive number multiplied by positive number is greater than 1. Now, do we know this for sure that multiplication of two positive numbers is always greater than 1? No, we do not know that. See, it's not saying that PQ are like they are integers. Okay, we do not know that. Now, even if they are integers, it may happen that both of them are 1, or both of one of them is 1, another is 2. We do not. The point is we do not know their actual values. So multiplication of two positive numbers may be greater than 1, may be equal to 1, may be less than 1. All of them are possible. We do not know which conclusion we'll land up into unless and until we have their exact values. Which means C also goes out. And hence our answer is option number. Hence our answer is option number. Alright guys, let's move on to the next question. Let's move on to question number 4. Pause the video and draw this question please. Okay, so 5 to the power n is less than 0.04. This is the question. So 0.04 is nothing but 0.04 is nothing but 4 by 100, which is like 1 by 25. So 5 to the power n is less than 1 by 25. This is the question. We do not know this. So 5 to the power n is less than 1 upon 5 square. So 5 to the power n is less than 5 to the power minus 2. So the question is actually, is n less than minus 2? This is the actual question asked. Is the value of n less than minus 2? If you're able to answer this, it's fine. If you're unable to answer this, then answer is E. So I'm going to remove all this. Now we have understood what the actual question is. So is n less than minus 2? Let's rewrite this here. is n less than minus 2. Statement number 1. 1 by 5 to the power n is greater than 25. 5 to the power minus n, or let me do this part also. So this will basically become 5 to the power minus 1 whole to the power n is greater than 5 square. 5 to the power minus n is greater than 5 square. Minus n is greater than 2, or n is less than minus 2. So do we have a conclusive answer for the question, is n less than minus 2? Yes, we do have. N is less than minus 2, which means when you'll write D, A, B, C, E, B, C, E, all three goes out. We have a conclusive result that n is less than minus 2. Okay, second statement. N cube is less than n square. So n cube minus n square is less than 0. N square taken common, n minus 1 is less than 0. Now product of two numbers is less than 0, which means one of them has to be positive, other one has to be negative. Now, is it possible for n square to be negative? No, which means n square has to be positive, which means n minus 1 has to be negative. So we will have n minus 1 as less than 0, which means n is less than. Now if n is less than 1, does that mean n has to be less than minus 2? Is it for sure? No. In this case, when n is less than 1, n can be greater than minus 2. N can actually be minus 2, or n can be less than minus 2. All three are possible. All three are possible. So do we have a conclusive answer from B? No. Which means D also goes out. Because statement 2 alone is not sufficient, which means our answer is option A. Which means our answer is option A. Alright. Let's move on to the next one. The last one for this video. Pause the question and try this video. Try this question, please. All right, so we have is xy plus xy is less than xy. This is like basically like you can subtract xy on both the sides, and the question is simply, is xy less than 0? It's a simple question. That is xy less than 0? Okay. Now statement number 1. X square by y is less than 0. Now if you have a by b less than 0, this works exactly like a into b less than 0. One of them positive, the other is negative. Now again, x square cannot be negative, right? X square has to be positive or 0. It can't be 0 in this case, otherwise the entire fraction will become 0. So x square will be positive, which means y has to be negative. So we have one conclusion from statement 1, that is y is negative. Now y is negative, so we have y negative and we have x square positive. But if x square is positive, does that mean x is also positive? If x square is positive, does that mean x is also positive? No. X can be positive as well as x can be negative. Both of them are true. Negative square is also positive. So do we know for sure that x is positive or negative? No, we don't know that. So if x is positive and y is negative, then the product is negative. But if x is negative and y is also negative, then the product is positive. Then the product is positive. So do we have a conclusive answer? No, we don't have that. So let's write D, A, B, C, E. A goes out, D goes out. Let's move on to statement number 2. So we have x to the power 9 y to the power 3 whole to the power 3 is again y to the power 9 is less than x to the power 8 into y to the power 8. Subtract x to the power 8, y to the power 8 on both the sides. We will have x to the power 9, y to the power 9 minus x to the power 8, y to the power 8 is less than 0. Or we could have done one more thing in this case. What we could have done is we can divide both sides by x to the power 8 and y to the power 8. The reason is that because x to the power 8 into y to the power 8, either it will be 0 or it will be positive. Okay. So x to the power 8, y to the power 8, because the powers are even, so either this will be positive or this will be 0. So let's take the first case when they are positive. So x to the power 8, y to the power 8 is less than 1, which means xy is less than 1. I'm considering them to be positive. Okay. So xy will be less than 1. So if xy is less than 1, is that sure that xy will be less than 0? No. No, we do not know that. And the second conclusion is where we are saying that x to the power 8, y to the power 8 is equal to 0, because this is the again the part we have to take into consideration. In that case, we can have x 0, we can have y 0, or we can have both of them zeros. So one thing is for sure that x into y is 0. But we do have a conclusive answer, but from statement 2 we are getting these two conclusions. Conclusion 1 is xy less than 1, and this is also xy is equal to 0, because you'll have to take both the parts into consideration. So again, do you have a conclusive answer from statement 2? No, you don't have, because you're getting multiple cases. Now, can we combine both of them? I don't think so we can do that. That is also not possible. So we do not have answers from A, D, B. We do not have answers from combination also, because we can't combine anything. It's not possible, which means our answer will simply become option number. Which means our answer will simply become option number E. Alright then guys, thank you so much for watching this video. I hope you are able to understand inequalities with data sufficiency in a better way after this video. So guys, keep watching and keep learning, and please do share and subscribe. If you have any questions, if you have any concerns, do let us know in the comment box. You can also drop us a mail, you can also drop us a WhatsApp. Okay, and do follow us on our Facebook page also. And if you have if you want to connect with us for any personalized classes on GMAT, GRE or SAT, then you can always ping us. We'll be happy to help you. Alright then guys, thank you so much. Take care and keep watching and keep learning.